Hello everyone. In this video, we will introduce the notion of permutations and we will see how many permutations in the linear case exist. So we have a formula for at least two cases here. Okay, so whenever it comes to counting different possible of ways of doing something, one of the key questions that you have to ask yourself at the very beginning is, does order matter? Or is there any specific arrangement for the set that I am choosing? So you may say, okay, how does that change, or what is the examples of these that in which the order matter? For example, when you're arranging people or objects in a line, when you look at from the left, the first object and second object and third object, they have intrinsic, they basically define the line. If you change the first and second person, you have formed different line. You have to see this versus when you choose a group of people or a team. Then in that case, you just have a bunch of people together and you call them a team, yes? So there is no first one or second one or third. There is a group of 4 people there. So in this case, the order matters. In this one, not. So it does not matter. Yes. So, but here we will work with the first case when the order or specific arrangement. For example, instead of having the first one, we may have that, okay, choose people and then call the first one Mr. A, second one B, or assign a duty A, B, C, and D. So that having different arrangement or order is what we call permutations. So what is permutation? Permutations of a set of objects is an arrangement for those objects or ordering of the given objects. As I said, this arrangement can be like having duties, the different duties, or order in a line. Okay, so now we want to count the number of arrangements for n objects. So how many permutations and different, or here I mean different objects have. So we want to count how many permutations. So here, whenever it comes to the permutations, and there is a word here that I'm now not writing, that's linear permutation. It's like, okay, there is a line or assignments or duties assigned. So in that case, you put them in an order in any way you like, and you have n object, n spots. Then the first object, the first spot, you have m possibilities. Then the second one has m minus 1. The third one has m minus 2. This will go up to, 2 and 1. And by the fundamental counting principle, you must multiply all these guys together, yes? And as you can see, this number, we already have a notation for that. That is n factorial. So the number of different permutations and linear permutations of n different objects is n factorial. So that is one of two formulas that you have to know for this part of the course. Okay, let's apply this in some examples. There are 5 different math books, 4 different chemistry, and 6 different biology books that we want to put them on a shelf. So putting books on a shelf, so you see there's an arrangement, left, first one, second one, and so on. If there are enough space for all the books on the shelf, how many arrangements here we have? So, okay, so we have 5 plus 4 plus 6, which is 15 different books. And we want to arrange them and count how many arrangements they have in a line. So basically we are looking for, so this is A, we are looking for all permutations, or the number of permutations of 15 different distinct objects here. So we first, then second, and this will go up to 15th, yes? And as we did above, the calculation or the formula we have, this is going to be 15 factorial. How about we have more condition on that? If there is enough space for all the books, and the books are to be grouped by subjects, it means that we put all math groups, so this is B, all math groups together, we group all chemistry books together, and all biology books are together. Well, they can have different order as well. So here B, C, M, or all other orders there. But the point is that the books, math books, should stick together. Chemistry books, they must stay together, and biology books are together. So when we're doing this kind of questions, there is this trick called grouping trick, and we divide our problem into 2 steps. So step 1 is that how many permutations of subjects we have. So we first fix in what order we put math, chemistry, biology. So there are 3 objects which are subjects here, and then we want to see how many permutations they have. Well, obviously they have 3 factorial. So we have now fixed what is the first subject, second subject, third subject. Then step 2, we are not done because we have not yet decided what is the order of the books in each category or each group of the subjects. Okay, so we want to then decide permutations of each of books in each subject, of books in each subject. Well, we start with math. For math, we have 5 objects, and they're all going to be together. So that means that they're going to form a line, and that will give me 5 factorial. Then I have to decide about chemistry, how many chemistry books we have, 4. So that will give me 4 factorial of permutations of chemistry. And for biology, we have 6. So altogether will give us 6 factorial. Now, my work is not done unless I do the step 1, then step 2, and step 2 itself, I must do each one of these orders. When I'm done, I have formed a permutation or an ordering with the required condition. By fundamental theorem, by fundamental counting principle, the number of this is going to be 3 factorial times 5 factorial times 4 factorial times 6 factorial. And here we go. We use this permutation, we break down our problem into 2 different permutations, and we find the number of ways we can arrange these guys on the shelf. So what we learned here was that we had n objects and we form a line or a ordering of all n objects. What about we have n objects, permutations of k objects out of n different objects? Well, what does it mean? It means that the spots available will be the first one, a second one, third one, and then this will go up to k minus 1 spot and the kth space. For the first one, we have n object to put, so I will start with n. Then the second one, sorry, let me just change this color here. So for the first one, we will have n possibility. For the second one, n minus 1. For the third one, n minus 2. And this will go for n minus k minus 1 plus 1 there. And then here, the last one will be n minus k plus 1. You always see this 1 here. We get 1 less than what is the order there. So if you multiply these guys, this is not n factorial anymore. So we have n times n minus 1 times, it will go up to n minus, I can write the first one as n minus k plus 2, and then n minus k plus 1. We multiply that. That's the number of such permutations. K objects out of n different one. But I want to write it in a nice way. So what I do here, I take this whole product and then I put it here, and then I continue multiplying the rest of this line up to the point that we get to the 1, to the number, so 2, 1. What I added here was the product, or multiplied there was the product of n minus k to 1. So I have to divide the same number to our total number there. But if you look carefully now, in the numerator, what we have generated is n factorial. In the denominator, what we have generated is n minus k factorial. So what we have shown is that the number of permutations of k objects out of n distinct or different objects is equal. It's not anymore just n factorial. You have to have n minus k factorial. Okay? So that is the second formula that you have to keep in mind. So we are not using all of the n objects that is available, only only k of them. Okay. So here, let's see this example. We're back to the original example. We have 5 math books, 4 chemistry, and 6 biology books. Now we have in how many ways we can arrange them on a bookshelf if there are only enough space for 10 books on the shelf. So we have 15 different books, and we are looking for number of permutations of 10 out of 15. And as the formula said, this is going to be 15 factorial divided by 15 minus 10 factorial, which is 15 factorial divided by just 5 factorial. Okay. Let's do another example here. In how many ways can the positions of president, vice president, treasurer, and secretary filled by an election from the members of 15 person board of the directors? So we have 15 members in this board of directors, and we want to choose 4 of them for different. So here we don't have the order, we have the arrangement, which is the same thing. So we are looking for president, vice president, treasurer, and secretary. And it is permutation. So we are basically looking for permutations of 4 people out of total 15. So as the formula suggested, this is 15 factorial divided by 15 minus how many rows or how many people we are going to put in the arrangement? 4. And that is 15 factorial over 11 factorial. Okay. So this way you have to know what is or what are permutations and what are the formulas, 2 formulas that we covered in this video.